Hello everyone, myself Hans. Today we are going to solve the problem of mechanics from topic central orbits. Here in the question, the law of central force is mu upon r cube. A particle is projected from an apse at a distance a with a velocity 2 upon a under root mu upon 3 at the orbit is r cos theta by 2 is equal to a. Let's solve the problem. Given central force is mu upon r cube. In a central orbit, u is equal to 1 upon r and the velocity is given by v is equal to 2 upon a under root of mu upon 3. Further we have to solve. We can also write the central force, that is P is equal to mu into u cube, because u is equal to 1 upon r. Further, the differential equation of central orbit is d2u upon d theta square plus of u is equal to p upon h square u square. Further we have to put the value of p in the differential equation of central orbit, that is the value of p is mu into u cube upon here is h square u square. From here u square to u cube is cancelled, remaining is u here, that is mu into u upon h square, and h square is cross multiplication with these terms d2u upon d theta square plus of u. We can also write that is h square bracket d2u upon d theta square plus of u is equal to mu into u. Further, the given differential equation multiplied by both the sides, multiplying both the sides by 2 du upon d theta and integrating. First we have to multiply both the sides by 2 du upon d theta, that is h square into 2 du upon d theta and into of d2u upon d theta square plus of here is u is already present, that is 2u du upon d theta is equal to here is mu and 2u is present, that is 2u du upon d theta, and we can write this in the differential form, that is h square bracket 2 du upon d theta and d square upon d2u upon d square is written as d by d theta of du upon d theta chi square. Further we have to differentiate with respect to theta, that is 2 du upon d theta and again du upon d theta differentiating with respect to theta, that is d2u upon d theta square. Further 2u du upon d theta is written as d by d theta of u square, and again we have to differentiate u square with respect to theta, that is 2u du upon d theta. We get the above result is equal to mu, and here 2u du upon d theta is also written as d by d theta of u square. Further we have to differentiate u square with respect to theta, that is 2u du upon d theta. and integrating both the sides, that is h square bracket, here integration is the inverse process of differentiation, so we have to write here du upon d theta का whole square plus of u square is equal to mu, and here is u square. Let the constant is a. Let this is question 1. And we know that velocity is given by v square is equal to h square and du upon d theta का whole square plus of u square. In a central orbit, velocity is given by v square is equal to h square bracket du upon d theta का square plus of u square. Further, we have to put the value of here in place of v square we have to put here h square bracket du upon d theta whole square plus of u square. Here is h square bracket du upon d theta whole square plus of u square. We have to put in place of v square, that is v square is equal to, here is mu into u square plus of a, and further in the question already given the velocity is given by 2 upon a under root of mu upon 3. Here we have to put the value of v square, that is v square is given by, on squaring both the sides, that is 2 to the 4 into mu upon 3a square. We have to put the value of v square here, that is 4 mu upon 3a square is equal to mu, and u square is written as, we know that at an x u is written as 1 upon a. At a distance already given, so we have to put here mu upon a square plus of a. Further, we have to find the value of a here, that is 4 mu upon 3a square, and plus of mu upon a square is taken to left hand side, that is mu upon a square is equal to a, and taking LCM here, that is 3a square, here is 4 mu, and here is 3 is not present, so I have to multiply with minus of mu with 3, that is 3 mu, and from here the value of a is 4 mu minus 3 mu, that is mu upon 3a square. Further, we have to put the value of a in the equation 1. Further, we have to put the value of mu a in the equation 1, that is at an apse theta is equal to 0. Once again, du upon d theta is equal to 0 and u is equal to 1 upon a. Further, we have to put in the equation 1 here, that is h square. In place of du upon d theta we have to put 0, that is 0 plus of, here is u square we can also write 1 upon a, that is 1 upon a square is equal to, here is mu, and into u square is written as 1 upon a, that is 1 upon a square, and we have to put the value of a here, that is mu upon 3a square. From here, that is h square upon a square is equal to, here we have to take the LCM, that is 3a square, and here is 3 mu, and plus of mu is equal to 4 mu upon 3a square, And from here we have to find the value of h square, that is a square cross multiplication, that is 4 mu 4 mu into a square and upon 3a square. From a square to a square is cancelled out, then the value of h square is 4 mu upon 3. Here we have to write the value of h square, that is h square is equal to 4 by 3 into mu, and the value of a is also written as a is equal to mu upon 3a square. Further we have to solve. Further we have to put the value of h square and a in equation 1, putting the value of a and h square in equation 1. Here h square, the value of h square is 4 upon 3 mu into, here is du upon d theta का whole square and plus of u square, and here is mu into u square and plus of the value of a is mu upon 3a square. From here we have to take common right hand side from mu, that is u square plus of 1 upon 3a square into mu, and from here mu to mu is cancelled out, then the remaining is du upon d theta का whole square plus of u square is equal to 4 upon 3 is cross multiplication with u square plus of 1 upon 3 a square, that is 3 by 4 into u square plus of 1 upon 3a square. Further we have to solve. That is du upon d theta का whole square plus of u square is equal to, we have to multiply this term, that is 3 u square upon 4 and plus of, plus of multiplying 3 by 4 with 1 upon 3a square, then 3 to 3 is cancelled out, then 1 upon 4a square, and from here plus of u square is taken into right hand side, that is du upon d theta का whole square is equal to 3 by 4 u square plus of 1 upon 4a square, and plus of u square is taken into right hand side, that is minus of u square, and taking LCM here, that is LCM is 4a square. Here is a square is not present, so I have to multiply the numerator with a square, that is 3 u square a square and plus of 1, and here is 4a square is not present, so I have to minus of u square is multiplied with 4a square, that is minus of 4a square u square, and from here that is du upon d theta का whole square is equal to, here is 3 u square a square minus of 4 a square u square, that is 1 minus of a square into u square upon 4a square. Further we have to taking a square root both the sides. Further we have to taking a square roots both the side, that is du upon d theta is equal to, here is under root of 1 minus of a square u square and upon 4 square is under root, that is 2a, and from here we can also write, that is under root of 1 minus of a square into u square is taken into denominator of du, that is du upon under root of 1 minus of a square into u square is equal to d theta is cross multiplication with here, that is d theta upon 2, and from here we have to let au is equal to t, that is a du is equal to dt, and from here we have to find the value of du, that is du is equal to dt upon a. We have to put in the given integral, that is in place of du we have to put dt upon a, and under root of 1 minus of, here is au का whole square, that is a square u square, we have to let au बराबर t, so we au is equal to t, so we have to put here t square is equal to d theta upon 2a, and from here a to a is cancelled out, and taking integration both the sides, that is we know the following identity in the integration, that is integration of dx upon under root of a square minus x square is given by sine inverse of x upon a. So we have to write here dt upon under root of 1 minus of t square is written as sine inverse of t upon a, here is in place of a we have to write 1, nothing to change, so we have to write only t is equal to, here is integration of d theta is theta, so we have to write theta upon 2 and taking constant as a b. Further we have to find the value of b here. At an apse theta is equal to 0, we have to put here, that is sine inverse of, in place of t we have to let au, so we have to put here au is equal to, in place of theta we have to put 0, that is 0 plus b, and from here we have to find the value of b, and we know that u is equal to 1 by a at an apse, so we have to put here, that is sine inverse of a into 1 upon a equal to b, and a to a is cancelled out, and we know that sine inverse of 1 is equal to b. We know that the the value of sine 90 is 1, so we have to put here, that is sine inverse of sine pi by 2 is equal to b, and from here sine to sine inverse is removed, so we have to value of b is pi by 2, and we have to put the value of b here, that is sine inverse of t is equal to theta by 2, and in place of v we have to put pi by 2 plus of pi by 2, and further taking sine inverse into this side, that is t is equal to sine pi by 2 plus theta by 2, and we know that sine 90 plus theta is cos theta, that is cos theta by 2, and we let earlier, that is t is equal to au, so we have to put here in place of t, that is au, and we know that u is equal to 1 upon r, in the earlier we have to let, so we have to put here a into, in place of u you have to put 1 upon r is equal to cos theta by 2, and further we have to write, that is r cross multiplication with this side, that is a is equal to r cos theta by 2. This is the required orbit path of the given central force. Here is we have to prove r cos theta by 2, r cos theta by 2 is equal to a. Thank you class, and thank you for watching. If any doubt, kindly comment in comment section.